So we know that density is a physical property, and we have a formula for density. Density is equal to mass over volume. And what we're going to begin doing now is solving problems using density formula in such a way that if we need to solve for density, we can. If we need to solve for mass, we can. If we need to solve for volume, we can. So you should have your worksheet in front of you, and we have the formula density is equal to mass over volume, and ideally as we progress with our math skills, we want to be able to take the formula density is equal to mass over volume, and we should be able to derive the other two formulas from it. So I'm going to recopy this. Density is equal to mass over volume. And so what I'm going to do is, if I want to solve this for mass instead of density, then what I want to do with my formula here is I'm going to take and multiply both sides of my equation by volume. Okay? And so here on the right side of the equation, the two v's, one's in the numerator, one's in the denominator, they cancel out. And then what I get is I've got volume times density is equal to mass. If I read that from right to left, that gives me mass is equal to density times volume. And so that's another formula that I have. I have the formula for mass. Now if I take this formula and I want to solve for volume, what I can do is I can take my equation, I want to divide both sides of my equation by density. Now that means on the right side of my equation, my densities, my d's for density are going to cancel, and what I'm going to get then is mass divided by density is equal to volume. Now again, if I read this from right to left, read this backwards, I've got volume is equal to mass divided by density, and that gives me the third formula. And so I have all three formulas, and I just derived them from the main formula, density is equal to mass over volume. Now ideally we should be able to do that, but that's just not where everybody's at, and that would be a little bit stressful to some students. And if you're feeling that that's stressful, then don't give up. Stay with me, because we're going to show you a shortcut so that it doesn't stay that mathy. And that shortcut is this triangle. Please understand this triangle is a memory device. It is not a formula, but it's a memory device that gets us to all three formulas. So if we're looking at this triangle and we want to know the formula for density, then just hold your thumb over the D and see what's left. The formula for density, D, is equal to what's left when you're blocking the D, M over V. And then if you want to know the formula for volume, then just block the V with your finger, block it. You've got volume is equal to, and look and see what's left. That is M over D. So volume is equal to mass over density. And if you want to know the formula for mass, then go ahead and just block the M with your finger and see what's left. That gives you mass is equal to D times V. Notice they're next to each other. They're not stacked. When they're stacked, you're going to take the numerator and divide by the denominator, but when they're next to each other, that suggests multiplication. So Mass is equal to density times volume. So what we have then is we are just using this triangle, and we still have three formulas. We have 1, 2, 3 formulas that are in our triangle, and we can find them very quickly. So again, that's a memory device. It does not replace a formula. It's not a formula. It shows us the formulas. Let's take a look at the problems that we're going to be working with. You always want to start your work by writing a formula. If you want to get credit for your work that you turn in, if your work is getting graded or it's on a quiz, you must write the formula first. If you don't have the formula, you will not get credit for your work. So we always start by showing our work with the formula. So let's take a look at the boxes there at the top of your page. It starts with giving you a 1A, B, and C from left to right. And they're just asking you then to find the unknown quantity. They also have some great hints. The triangle is there, and then there's some information here about what does units of density look like. Density units always have the slash because you're dealing with mass divided by volume. You're always going to have a mass unit and a volume unit with a slash there. That's called a derived unit. And so units of density look a little bit different, but that's because you've got a mass and a volume unit together. And you'll see that as we move along. But that's just to remind you, what are your density units going to look like? You should know that when we talk about mass, that's grams. Mass, we have been using grams. We measure grams in the lab. You should know that mass is going to be in units of grams, and you should also know that volume is going to be in units of milliliters. When we work in the lab, our volume is in units of milliliters. So when we take this first one, it's asking us for mass, so we're going to block the M in the triangle and write down the formula. Mass is equal to density times volume, and then you're just going to fill in the pieces. The density they give you is 3. Always include the unit, gram per mil. Okay, and then the volume, we're going to multiply by that volume, which is 100 mil. And so 3 times 100 is going to give us 300. I do not like this stylus I'm working with. And I don't know where my other one is, so this is the one I have. So we have 3 times 100 is 300. What happens with our units? Well, milliliter is going to cancel with milliliter, and your answer is going to be in grams, and that's good because we want mass, and mass is in grams. So our answer looks good. We have a unit that makes sense to us. Let's take a look at the next one. We're filling in the one that's missing. We want to know density. Cover the D in our triangle to remember our density formula. Density is equal to mass over volume. Fill in the mass and the volume with what they give you. They're giving us a mass of 95 grams, and then they're giving us a volume of 950. I'm going to keep my unit in there. Don't leave your units off, okay? That's a good way to lose points. Then I want to encourage you, go ahead and use a calculator to do some of this simple math, because that just keeps you from making mistakes. You're learning some new things, and use that calculator support for some of the math. The reason why I'm mentioning that is because with this problem, students very often tell me that the answer to this is 10. And I want you to understand, you've got a numerator and a denominator here. You need to put the numerator into your calculator, and then you're going to divide by the denominator. And if you do that, you're getting an answer of 0.1. Answer 0.1. And look at our units. Nothing cancels here, so our units are going to be gram / ml, similar to what we see at the top of the page, gram/ml, 0.1. Let's look at C. For C, they're asking us to calculate the volume, so we're going to go ahead and use the memory chart, cover the V, find out that V is equal to mass divided by density, write the formula down. Formula is the first step to getting points here, and then we're going to fill in the pieces from the information they gave us. What is our mass? Our mass is 20 grams. And then our density is 0.5 grams per centimeter cubed. You want to have all of that. Okay. So go ahead and use a calculator to check your work. Don't let little math mistakes bring your grade down when you can use a calculator for that support, okay? 20 divided by 0.5, you're going to get 40. And then what happens with our units here, okay? So you have gram in the numerator, and then the denominator, you have gram per centimeter cubed. So your grams are going to cancel with grams. And then it's kind of interesting, this centimeter cubed. It's in the denominator, but it's in the denominator of the denominator, if you will. So what I want you to remember is when you divide by a fraction in math, what you're really doing is multiplying by the reciprocal, which of course is the upside down version of that fraction. So really what we're doing here is we're taking grams and we're multiplying by centimeter cubed over a gram, and that's why the 2 grams cancel and we end up with centimeter cubed in our answer, okay? And that should make sense to us because volume units are going to be centimeter cubed. Centimeter cubed, remember, is the same thing as a milliliter, but we tend to use centimeter cubed for solids and milliliters for volumes of liquids. So when we look at number 2, A, B, and C, those require us to do some metric conversions. So here in the first one, A, we're supposed to take 1.2 liter and convert it to milliliter. The reason why is, look at our units. We need our volume to be in units of milliliter to cancel out correctly with our units of density, our units that we have for density. So we can think about the fact that we can take liters and multiply by 1,000 to get milliliters, or just move the decimal. We talked about this method. We're just going to go 1, 2, 3 places over, and so what you're going to have there is 1, 2, 0, 0 milliliters. And so now with that volume, we're going to be able to go ahead and solve the problem. Mass is equal to density times volume. They're giving us a value with a unit for density. We want to copy that in. Don't leave anything out. If you want credit for your work, don't leave these units and these numbers out. Gram per mil is my density, and then I'm going to multiply that by my volume, which I just converted, and that's going to be 1,200 milliliters. Okay, now look what happens to our units. Our milliliters are going to cancel. One's in the numerator, one's in the denominator, and we're going to do the math. And we're going to get 28,800. that's going to be in grams, and mass is in grams. Emma, what are you doing? I have a dog that's getting into something. Okay, so stay in here, Emma. Good girl. So let's look at the next one. It tells us that we need to take kilograms and convert that into grams. And we can think about how there's 1,000 grams in every kilogram, so we could multiply by 1,000, or we can use the move the decimal method. We want to go from kilograms over, it's going to be 1, 2, 3 places over, so we're going to have 1, 2, 3, and that's going to be our grams. We're solving for density. We can cover the D. Use density is equal to mass over volume. We've got our mass. And we've got our volume. And 1,500 divided by 100 is 15. And there's our units. Nothing cancels here. Density units always have that slash, so expect that. That's not unusual at all. Okay, so when we get to 2C, there's two conversions that they want us to make. So we want to take our liters and convert that to milliliters. Going to move our decimal over 1, 2, 3 places. And notice with milligram, we're going to be moving our decimal the other direction because there's 1,000 milligrams in a gram. So we're going to end up with 0.5 grams. And now we want to solve for density. You put your mass in. Always include the unit. Okay, and then always remember you're going to take your numerator and divide by the denominator. Look at that number. That would be a good number to convert into scientific notation. And our units do not cancel. Okay. That was also a good one to talk about significant figures and how we would want to round that down because our measurement here only has 1 sig fig. So we would actually want to answer that with one significant figure, but that's a topic for another day. So let's look at our word problems. Number 1, I'm not going to help you with number 1. You can do that one. Look at what it asks you. What is the density? You're going to go ahead, determine your formula for density, write the formula, then put the numbers in with the units, and answer with a number and a unit. So number 1, you can do without me. I'm not helping with that one. I'm also not helping with number 2. You're looking for density, use the triangle if you don't remember the formula for density, but it's right there on the worksheet at the top. Use the formula for density and put the numbers in with their units, do the math, show an answer with a unit. Number 3, what is the weight or mass of the ethanol that fills a 200 milliliter container? The density of ethanol is 0.789. Well, look and see what they're asking you for. Bottom line, they're asking you for mass. So you're going to use your triangle, look for the formula. Mass is equal to density times volume. Now plug in the density that they give you and the volume that they give you, and you should be able to solve that for mass. Make sure you include your units when you write your numbers into your work, and include a unit at the end. And if they're asking you for mass, you should know what unit you're going to end up with, because you know what units of mass look like. Number 4. Number 4 I am going to help you with. So let's look at that one together. A rectangular block of copper metal weighs 1,896 grams. The dimensions of the block are 8.4 centimeter by 5.5 centimeter by 4.6 centimeter. First of all, you might be noticing they're giving us a lot of numbers, so something seems a little different. Okay. It says, from this data, what is the density? So if it's asking you for the density, start with the density formula. Look at your triangle. Density is equal to mass over volume. We know we're going to need that formula if we're going to calculate the density. Then we also know that if we're going to calculate the density, then they need in that problem somewhere to give us a mass, and they need to give us a volume. So let's see what they gave us. Did they give us a mass? Yes, they did. There's a mass there. You might want to mark it. There's the mass. Okay. Did they give us a volume? That's the part that's tricky. They did not. They did not give us a volume. They gave us the dimensions, and the hint is, what is the formula for volume? Do you remember how to calculate the volume of a cube or a block? It's length times height times width. So what you're going to do is go ahead and calculate the volume with these dimensions. And that number is going to be put into our density is equal to mass over volume. So we're going to start by taking these numbers and calculating the volume first. Okay, so we have 8.4 centimeters times 5.5 centimeters times 4.6 centimeters. Okay. And look what happens with our units. Centimeter times centimeter times centimeter is going to be centimeter to the third, which we know that is a unit of volume. And then once we have our unit of volume, which I'm getting 212.52, now we're going to take that and we're going to plug that into our volume in our density formula. So now we have our mass and we have our volume, And we can plug those numbers into our formula. And there we have it. So we calculated our volume from the dimensions and put that in to our density formula. So density is still mass over volume. We ended up with units that did not cancel. I don't know why my G is not showing there. And so our answer then is in grams per cubic centimeters. Grams per cubic centimeters. Right there. Okay? So I hope you took notes on number 4, because number 7, it's just like number 4, and I'm not helping you with that one. That one you're going to do. So make sure you took notes on how to do number 4. Number 5, let's look at this one. What is the volume? So we can tell automatically we're going to need to know volume. So use your triangle. Cover the V. Volume is going to be equal to mass over density. Do they give us a mass? They do. Did they give us a density? Sure they do. So we're going to just go ahead and show a formula, plug our numbers in to that formula. And we know grams are going to cancel. And then our answer is going to be in centimeter cubed. I'm going to let you finish that one. Number 6, what's the mass? You can do that one. Okay. Get your formula for mass, write your formula down, substitute the numbers from the problem into your formula for mass, and solve for the mass. Number 7, remember I told you that's just like number 4. So you're going to have to calculate the volume and then put the volume in just like number 4. I'll let you do that one. And then I want to talk to you briefly about this idea. If we have a liquid, then we always use a graduated cylinder to get the volume of that liquid. We've been doing that. And what we just did in the last problem is we calculated the dimensions of a block to get the volume. But what if our object is shaped kind of weird? What if we can't find length times height times width because it's irregularly shaped? Well, with that situation, we get our volume with a method called volume by water displacement. This is something you want to know. You might want to write that in your notes. Volume by water displacement. So what we're going to do is we're going to take that object that's shaped kind of crazy. We can't get length times height times width from that. And we're going to find a graduated cylinder that's big enough that the object will go into that graduated cylinder. And then we're going to carefully add water to that. And we're going to read that for accuracy. We're not just winging it. We want to read that. And in this one, my estimate is a 0. I believe that's 7.0 units of volume there, 7.0. And once we see what that volume is, then we're going to drop that object into our graduated cylinder, and it's going to take up space equal to its volume, right? That's the amount of space that it takes up. That's what volume is. And when it does that, it's going to push the volume of the water up by an equal amount to its volume. So however much the water goes up from 7, that's the volume of this object, because it's going to push that volume of the water up. So we're going to read it afterwards. Afterwards, it looks like 9.0 to me. My estimate is the 0. And now I'm just going to subtract. I'm going to take my 9.0 and subtract my 7.0. Okay, and that is 2 units of volume there. So this object has a volume of 2 of the units. 2 units. It's called water displacement. We're displacing the water to to get the volume of the object. That's important, and use that in number 8. So let's look at number 8. It says 28.5 gram of iron shot. Iron shot means pieces of iron that are round. They're not big like a marble, but they're little round pieces of iron. And iron shot is added to a graduated cylinder containing 45.50 mil of water. Water's already in the graduated cylinder. When we add the iron shot, the water rises to 49.10. From this information, calculate the density. Well, you know, if they're asking you for density, you want to go ahead and say, okay, I'm going to be using the density formula. Density is equal to mass over volume. Does it give me a mass? Yeah, it does. Did it give me a volume? It gave me 2 volumes. Why are there 2 volumes? Because we're using water displacement to get the volume of the object. So the mass they gave us, but we need to subtract the final volume, take the final volume and subtract the original volume, and that's going to give you the volume of your irregularly shaped object. Okay, so when we do that subtraction, this is our volume of our object. They gave us the mass of the object. Now it's just a straight density is equal to mass volume problem. We're going to plug those in, the mass, the volume, and divide to get the answer. Okay, so that's the first worksheet. You're going to finish the ones that we didn't finish here, okay, and then you're ready to go on to set 2. There's another set of density problems as well.